it is vital to critically assess the information provided by inspectors and to rely on reputable sources such as manufacturers and industry experts to ensure accuracy. An individual failed a final inspection on a new house because an arc fault circuit interrupter, also known as an AFCI breaker, would not trip using the inspector's tester. The individual contacted the breaker manufacturer, Square D, and the tester manufacturer, Ideal, and confirmed that the breaker's test button was the only Underwriters Laboratories, also known as UL, approved method of testing. The inspector, despite being presented with this evidence, insisted that the tester was accurate and demanded that the breaker be replaced. The individual refused and contacted the manufacturer of the tester, who confirmed that it was not compatible with Square D breakers. The inspector reluctantly accepted the manufacturer's guidance and signed off on the inspection, but admitted that other inspectors typically changed out breakers until they worked with his tester, a practice that the homeowner deemed unacceptable. The Underwriters Laboratories approved method for testing of AFCI breakers is using the breaker's test button. Inspectors should rely on reputable sources and follow industry standards when conducting inspections. It's important to question inspectors' methods and seek clarification when necessary. Individuals should not feel pressure to replace working equipment based on an inspector's faulty information. Now let's delve into AFCI breakers, their purpose, and proper testing methods, referencing relevant sections of the National Electrical Code, also known as AFCI, where applicable. An AFCI breaker is a circuit breaker that detects electrical arcs, which are dangerous unintended electrical discharges, and quickly disconnects the circuit to prevent electrical fires. These breakers are designed to protect against fires caused by arcing faults, which can occur in damaged or deteriorated wiring, loose connections, or faulty appliances. There are two main types of arcs that AFCI breakers detect. Firstly, series arcs, which occur when a wire is broken or a connection is loose, and secondly, parallel arcs, which occur between two conductors with different potentials. The NEC requires AFCI protection in many areas of a home, particularly in bedrooms, living rooms, and other areas where occupants are likely to be present. This requirement has been expanded over time to include more areas as the technology has improved and the understanding of arc fault hazards has increased. The purpose of these requirements is to enhance safety and reduce the risk of electrical fires. Section 210.12 of the NEC outlines the specific requirements for AFCI protection in dwelling units. It typically requires that all 120-volt, single-phase, 15-amp and 20-amp branch circuit supplying outlets or devices installed in dwelling units must be protected by AFCI breakers. This includes outlets in kitchens, family rooms, dining rooms, living rooms, parlors, libraries, dens, bedrooms, sunrooms, recreation rooms, closets, hallways, laundry areas, and similar rooms or areas. There are exceptions to these requirements, such as for outlets that supply only a fire alarm system or other critical safety equipment, where interruption of the circuit could create a greater hazard. It's important to consult the latest version of the NEC and local amendments to determine the specific requirements in a given jurisdiction. AFCI breakers use sophisticated electronics to detect the unique characteristics of arc faults. These breakers monitor the current and voltage waveforms in the circuit and look for patterns that indicate the presence of an arc. When an arc is detected, the breaker quickly trips, cutting off the power to the circuit and preventing a fire. The test button on an AFCI breaker simulates an arc fault condition, allowing the user to verify that the breaker is functioning properly. When the test button is pressed, it creates a small internal arc that should cause the breaker to trip. This is the Underwriters Laboratories approved method for testing AFCI breakers and is the most reliable way to ensure that the breaker is working as intended. Using a non-compatible tester can produce misleading results and should be avoided. Inspectors and electricians should rely on the test button as the primary method for verifying the functionality of AFCI breakers. Some inspectors use specialized testers to evaluate AFCI breakers, but these testers are not always compatible with all brands and models of breakers. As demonstrated in the scenario, using an incompatible tester can lead to false negatives, where the breaker fails to trip even though it is functioning correctly. It's important for inspectors to be aware of the limitations of their testing equipment and to follow the manufacturer's recommendations for proper testing procedures. When an inspector uses a tester that is not compatible with a particular AFCI breaker, it can create confusion and unnecessary delays. In such cases, it's important to communicate with the inspector and provide documentation from the breaker manufacturer and the tester manufacturer regarding compatibility. Inspectors should be willing to consider this information and adjust their testing methods accordingly. If an inspector insists on using a non-compatible tester, it may be necessary to escalate the issue to a higher authority such as the local building department or the electrical inspection board. In a scenario, the individual encountered an inspector who was reluctant to accept the manufacturer's guidance and insisted that the breaker be replaced. This highlights the importance of standing your ground and advocating for your rights as a homeowner. If you believe that an inspector is using improper testing methods or is making unreasonable demands, it's important to document your concerns and seek clarification from reputable sources. You should also be prepared to challenge the inspector's decision and provide evidence to support your position. The individual in the scenario contacted both the breaker manufacturer and the tester manufacturer to gather information and support their case. This demonstrates the importance of doing your research and being prepared to present your findings in a clear and concise manner. In addition to contacting the manufacturers, you may also want to consult with a qualified electrician or electrical engineer to get a second opinion. These professionals can provide expert guidance and help you navigate complex electrical issues. It's also important to be familiar with the electrical codes and standards that apply in your jurisdiction. The NEC is a comprehensive set of guidelines for electrical installations, and it provides valuable information on the proper installation, testing, and maintenance of AFCI breakers. By understanding the code requirements, you can better assess the inspector's methods and ensure that your electrical system is safe and compliant. When dealing with electrical inspections, it's important to maintain a professional and respectful demeanor. While it's important to advocate for your rights, it's also important to avoid getting into arguments or confrontations with the inspector. Instead, focus on presenting your case in a calm and rational manner, and be willing to listen to the inspector's perspective. Remember that the inspector's job is to ensure the safety of the electrical system, and their recommendations should be taken seriously. However, it's also important to recognize that inspectors are human and can make mistakes. If you believe that an inspector is making an error, it's important to address the issue in a constructive and collaborative manner. In some cases, it may be necessary to compromise or find a mutually acceptable solution. For example, you may be able to agree to have a qualified electrician perform additional testing or make minor modifications to the electrical system to address the inspector's concerns. Ultimately, the goal is to ensure that the electrical system is safe and compliant while also respecting the rights and responsibilities of all parties involved. In addition to AFCI breakers, there are other types of circuit breakers that are designed to protect against different types of electrical hazards. Ground fault circuit interrupter, also known as GFCI, breakers are designed to protect against electrical shock by detecting ground faults, which occur when electricity flows through an unintended path, such as through a person's body. GFCI breakers are typically required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. Dual-function breakers combine AFCI and GFCI protection in a single device. These breakers are becoming increasingly popular as they provide comprehensive protection against both arc faults and ground faults. When selecting circuit breakers for your home, it's important to choose the right type and size for each circuit. The size of the breaker should be matched to the amperage of the circuit to prevent overloading and overheating. It's also important to choose breakers that are underwritten as laboratories listed, meaning that they have been tested and certified to meet safety standards. Section 240 of the NEC provides detailed requirements for overcurrent protection, including circuit breakers and fuses. This section specifies the maximum allowable current for each circuit and the required size of the overcurrent protection device. It's important to consult this section of the code when selecting circuit breakers to ensure that they are properly sized and installed. The NEC also provides guidance on the proper installation and wiring of circuit breakers. This includes requirements for the enclosure, the wiring connections, and the labeling of the breakers. It's important to follow these requirements carefully to ensure that the circuit breakers are installed safely and correctly. Regular maintenance of circuit breakers is also important to ensure their continued reliability. This includes periodically testing the breakers to verify that they are functioning properly and inspecting the breakers for any signs of damage or deterioration. If a circuit breaker trips frequently or shows signs of damage, it should be replaced immediately. When replacing a circuit breaker, it's important to turn off the power to the circuit at the main electrical panel. This will prevent electrical shock and ensure that the replacement can be done safely. It's also important to choose a replacement breaker that is the same type and size as the original breaker. If you're not comfortable replacing a circuit breaker yourself, it's best to hire a qualified electrician to do the work. They have the knowledge and experience to ensure that the replacement is done safely and correctly. In addition to circuit breakers, there are other electrical safety devices that can help protect your home from electrical hazards. Surge protectors are designed to protect electronic equipment from voltage spikes, which can damage or destroy sensitive components. Surge protectors are typically installed at the main electrical panel or at individual outlets. Smoke detectors are designed to detect smoke and alert occupants to the presence of a fire. Smoke detectors should be installed on every level of the home and outside of each sleeping area. Carbon monoxide detectors are designed to detect carbon monoxide gas, which is a colorless, odorless gas that can be deadly. Carbon monoxide detectors should be installed on every level of the home and near sleeping areas. By taking these precautions and following the electrical codes and standards, you can help protect your home and family from electrical hazards. Remember, electrical safety is a shared responsibility, and it's important to be proactive in identifying and addressing potential electrical problems. Electrical systems are complex and potentially dangerous, and it's important to consult with qualified professionals when dealing with electrical issues. Whether you're planning a new electrical installation, troubleshooting an existing problem, or simply seeking advice on electrical safety, a qualified electrician or electrical engineer can provide valuable guidance and expertise. These professionals have the knowledge and experience to ensure that your electrical system is safe, compliant, and reliable. They can also help you navigate the complex world of electrical codes and standards and ensure that your electrical system meets all applicable requirements. When hiring an electrician or electrical engineer, it's important to choose someone who is licensed, insured, and experienced. You should also check their references and review their past work to ensure that they are qualified to handle your project. It's also important to get a written estimate before starting any electrical work. The estimate should include a detailed description of the work to be performed, the materials to be used, and the total cost of the project. This will help prevent misunderstandings and ensure that you are getting a fair price for the work. Finally, it's important to communicate clearly with your electrician or electrical engineer throughout the project. Be sure to ask questions if you don't understand something, and don't hesitate to express your concerns. By working together, you can ensure that your electrical project is completed successfully and that your electrical system is safe and reliable. Now let's consider some additional points regarding electrical inspections and dealing with inspectors. When preparing for an electrical inspection, it's helpful to gather all relevant documentation such as electrical permits, wiring diagrams, and equipment specifications. This will make it easier for the inspector to review the electrical system and verify that it meets all applicable requirements. It's also helpful to walk through the property with the inspector and point out any specific areas of concern. This will give the inspector a better understanding of the electrical system and help them identify any potential problems. During the inspection, it's important to be respectful and cooperative. Answer the inspector's questions honestly and provide any information that they request. If you disagree with the inspector's findings, it's important to express your concerns in a calm and rational manner. You may want to provide additional documentation or consult with a qualified electrician to support your position. If you are not satisfied with the outcome of the inspection, you may have the right to appeal the inspector's decision. The appeals process will vary depending on your local jurisdiction, but it typically involves submitting a written appeal to the building department or the electrical inspection board. In your appeal, you should clearly state the reasons why you believe the inspector's decision was incorrect and provide any supporting documentation. You may also be required to attend a hearing or meeting to present your case. It's important to remember that the appeals process can be time-consuming and may not always result in the outcome you desire. However, it's an important avenue for ensuring that your rights are protected and that the electrical system is inspected fairly. In conclusion, understanding AFCI breakers, proper testing methods, and your rights as a homeowner is crucial when dealing with electrical inspections. Rely on reputable sources, question inconsistencies, and ensure your electrical system meets safety standards.